When we solve problems involving triangles, we could use the sine rule and the cosine rule along with the standard trigonometric ratios for right-angle triangles and the Pythagoras theorem. Now, I've already covered the sine rule, the cosine rule, the Pythagoras theorem and standard trigonometric ratios for right-angle triangles in my previous Pure Maths videos, so if you want, check them out for more details. Now, when dealing with problems involving triangles, if the triangle is a right-angle triangle, we could try using the Pythagoras theorem and basic trigonometry. And if the triangle is not a right-angle triangle, we can decide whether to use the sine rule or the cosine rule. Now, in a triangle, if we were asked to find an unknown angle given two sides and one opposite angle, we can use this version of the sine rule. And if we were asked to find an unknown side given two angles and one opposite side, we can use this version of the sine rule. Now, in a triangle, if we were asked to find the size of an unknown angle given the length of all three sides, we can use this version of the cosine rule. And if we were asked to find the length of an unknown side given two sides and the angle between them, we can use this version of the cosine rule. Now, in triangle problems for questions involving area, we can check whether we could use the formula area equals half times base times height before using the formula involving sine. If not, and we were asked to find the area given the length of two sides and the angle between them, we can use the formula area equals half AB sine C. So first, let's take this example, calculate the total area. So, this triangle is composed of two other triangles which are not right angled. Now, before calculating the area, let's label this triangle as ABCD. So here, we know the lengths of AB, BD and DC and the angle BAC. Now here, we can calculate the total area of the triangle ABC using the formula area equals half AB sine C. But in order to use this formula here, we need to know the length of AB, AC and the angle in between the two sides. Since we know the angle as 75 degrees and the length of AB as 3.9 centimeters, we need to find the total length of AC. So here AC equals AD plus DC. We know the length of DC, so now let's find the length of AD. To find the length of AD, first let's find the angle ADB. So here we can use the sine rule since we know the length of two sides and the angle opposite the side BD as 75 degrees. I label this angle x. So using the sine rule in the triangle ABD, sin x over 3.9 equals sin 75 degrees over 4.8. Sin x equals 3.9 times sin 75 degrees over 4.8. Take the inverse of sin, then x equals sin inverse 3.9 times sin 75 degrees over 4.8. X equals 51.7035 degrees. X equals 51.7 degrees. Now, let's find the angle ABD. Since angles in a triangle add up to 180 degrees, the angle ABD equals 180 degrees minus 75 degrees plus 51.7035 degrees equals 53.2965 degrees. Now, in the triangle ABD, since we know the length of the two sides AB and BD and the angle in between them as 53.2965 degrees, we can use the cosine rule to find the length of AD. So, using the cosine rule, AD squared equals 3.9 squared plus 4.8 squared minus 2 times 3.9 times 4.8 cos 53.2965 degrees. AD equals 3.9841 centimeters. So, the length of AC equals 3.9841 plus 2.4 equals 6.3841 centimeters. So, the total area of the triangle ABC equals 102 times 3.9 times 6.3841 times sin 75 degrees equals 12.0 centimeters squared. Here, I gave the final answer to three significant figures. Now, let's take a look at a few more examples. Calculate the value of x. X centimeters is the length of AD. So, in this triangle, we know the lengths of all three sides but don't know any angles. So, now in order to find the value of x, first I'll find an angle inside the triangle ABC. Now I'll take the angle ABC, so I'll label this angle y. Now since we know the length of all three sides in this triangle as 12.3 centimeters, 15.6 centimeters and 20.4 centimeters, we can use this version of the cosine rule to find the angle y. So using this formula, cos y equals 20.4 squared plus 12.3 squared minus 15.6 squared over 2 times 20.4 times 12.3. cos y equals 324.09 over 501.84. Take the inverse of cosine, then y equals cos inverse 324.09 over 501.84, y equals 49.8 degrees. Now, since we know the size of the angle ABC in the triangle ABD, we can use basic trigonometry to find the value of x. So here we can use the sine ratio, then sine y equals x over 12.3 as sine theta equals opposite over hypotenuse. X equals sine y times 12.3, x equals 9.39 centimeters. Moving on to another example, calculate the size of the angle x. So here we know the lengths of AD, DB and AC. Now the angle x is inside the triangle ACD. And here we don't have enough data to calculate the angle x. So here we are given this angle as 50 degrees. As we all know, angles on a straight line add up to 180 degrees. So we can calculate the angle ACB. So the size of the angle ACB equals 180 degrees minus 50 degrees equals 130 degrees. Now let's find the size of the angle ABC. I label this angle y, so the total length of AB equals AD plus DB, then AB equals 2.4 plus 8.6 equals 11 centimeters. Since we know the length of two sides and the angle opposite the side AB as 130 degrees, we can use this version of the sine rule to calculate the size of the angle ABC. Now, using the sine rule, sine y over 3.8 equals sine 130 degrees over 11. Sine y equals 3.8 times sine 130 degrees over 11. Take the inverse of sine, then y equals sine inverse 3.8 times sine 130 degrees over 11. Y equals 15.345 degrees. Y equals 15.3 degrees. Angles in a triangle add up to 180 degrees. Hence, in the triangle ABC, the size of the angle BAC is 180 degrees minus 130 degrees plus 15.345 degrees equals 34.655 degrees. Now, in the triangle ADC, we know the length of two sides AD and DC and the angle in between as 34.655 degrees. So here, we can use the cosine rule to find the length of DC. So using the cosine rule, DC squared equals 3.8 squared plus 2.4 squared minus 2 times 3.8 times 2.4 cos 34.655 degrees. DC equals 2.279 centimeters. Now, since we know the angle BAC and the length of DC and the length of the side opposite the angle x as 2.4 centimeters, we can use the sine rule to calculate the angle x. So, using this version of the sine rule, sin x over 2.4 equals sin 34.655 degrees over 2.279. Sin x equals 2.4 times sin 34.655 degrees over 2.279. Take the inverse of sin, then x equals sin inverse 2.4 times sin 34.655 degrees over 2.279. X equals 36.8 degrees.